Hi everyone, so now that we know how to graph square roots, we're going to move on to graphing nth roots. Okay, so here's another SAT question. Remember the SAT for juniors is on March 24th. And that day, the sophomores and freshmen will also be taking the PSAT. All right, so pause. I think this is a calculator problem because of the decimals, so you can use your calculator to do this. All right, so I actually didn't use a calculator. What I looked at was, okay, I have 1.5x minus 2.4 squared. So that's going to give me a trinomial. And then I'm subtracting off this. So I automatically knew that A and B were wrong because they're binomials. And then if you notice with C and D, the A and B term are the same. So all we really needed to do was figure out the C term. So the C term would be coming from negative 2.4 squared minus negative 6.4. So 2.4 squared, if you square 25, 25 squared is 625. So I know this is around 6 and change. 6 and then plus 6.4. So automatically, without even doing any real work, I was able to figure out it was C. So, I mean, you could do the whole problem out, but, you know, if you're having trouble or you just want to be lazy like me, you could do it that way too. Okay, so what would a cube root look like? Remember when you start off graphing and you have no idea what something looks like, start with a table. So let's think about what can we plug into a cubed root? What are our perfect cubes? Right. So look on your sheet. So our perfect cubes are 1, 8, 27, 64, and so on. Right. So I know I want to plug in 1. I want to plug in 8. What else should I plug in? 0. Anything else? Now, since it's a cubed root, are we able to take the cubed root of negatives? Should we include negatives? We can. So actually, I'm going to erase this. So what I did was negative 8, negative 1, 0, 1, 8. Because you can take a cubed root, right? 3 negatives, a negative times a negative times a negative is a negative. So you can have negatives here. Right? The cubed root of negative 8 is negative 2. The cubed root of negative 1 is negative 1, 0, 1, and then 2. So those are our 5 points. So plot those and see what this looks like. So I got negative 8, negative 2, negative 1, negative 1, 0, 0, 1, and then 8, 2. So look at what this guy looks like. What does that remind you of? All right, if you're watching this on like your phone or something, try turning it. It might flip, or turn your head. This actually looks like a negative x cubed if you turn your head, right? This is that inflection point that we talked about when we're graphing polynomials. So that's what happens here because it's the inverse of x cubed, so it tends to look like an x to the third, but it's on its side. All right. Notice you can go positives and negatives on like a square root. Now the shifting rule, just like a parabola, just like a square root, is going to be really similar. So I want you can make a table or think about the shifting rule. What would you do to graph this? So pause and try to graph it. So my vertex point, or my starting point, I never know what to call it, starting point, is change the sign of the inside, outside stays the same, right? What will make the inside 0, and then our y value. Right? So I'm starting at 4, negative 2. Now, the over and up, right? This is all based on that cubed root. What cubed roots do we know? The cubed root of 1 is 1. The cubed root of 8 is 2. But remember, we're going in both directions. So over 1, up 1, over 1, down 1, right? Over 8, up 2. Now, I can't quite fit this on here. I can kind of estimate it. So let's see, that's 6, 7, 8, up 2. So I'm like there, down 2, over 8. or over 8 down 2. Right there. So if you didn't include that one, that's off, that's fine. So just, I'm basically using this and kind of keeping in mind, this is what my parent function looks like. So it's that 1182 that we're going to be using. All right, same idea. What do you think about this one? Pause and try it on your own. So my starting point, again, what will make the inside 0, the outside is 5. What is that? Because that -2 is multiplying. What do you do when something's multiplying? You multiply your what? Your up, down. Right? So normally it's 1182. So we're going to multiply the up times -2. -2, -4. So my starting point is 0, 5. 1, 2, 3, 4, 5. Now normally we go right and up, so what are we going to do this time? We're going to go right and down, right? Opposite sign. And then I'm going to go over 8, down 4. 1, 2, 3, 4. Over 1, up 2, and then over 8, up 4. There it is. That is such a bad drawing. Sorry. Sometimes the way I put my iPad, it's just awkward looking. Let's see if I can do a better job at this. Ugh. This is so terrible. I'm sorry. Oh my gosh. I gotta erase this. I can't even handle it. I can't handle it. It's terrible. Oh. Even a teacher. 1, 2, 3, 4, 5. 8. 1, 2, 3, 4. 8. 1, 2, 3, 4. Okay, let's try this again. I'm going to sit a little differently. Still not amazing, but it's better. All right, so that's our cubed root. So notice it's just once we figure out what's happening with the parent function, the whole shifting rule just helps and it makes life easy. All right, so now we're going to do one that's a little different. This is x to the 2/3. So try again, plug some numbers in. What do you think? Remember, to the 2/3 would be the cubed root of x squared. Since it's a cubed root, we can do those same numbers. What is the cubed root of -8 squared? So remember, the cubed root of -8 is -2, and then we square that and we get 4. So we get 4, 1. Because of the square, it's flipping it positive, 0, 1, 4. Right? So I always do the root first. The cubed root of -1 is -1. -1 squared is 1. All right, let's see if I can do a little better job of this. -1, 1, 0, 0. So what does this look like? I like to say that this looks kind of like a bird. You know, when you're like a kid or, you know, an adult female who can't draw, and you're drawing like a scenery, and in the background you have like a little birds, right? That's what this looks like to me. I always call this the one that looks like a bird. So yeah, because of that squared, instead of going down, it flips it back up. Okay, so now 4th root. So pause the video and try this one on your own. What are your perfect fourths? So 0, 1, and then what's next? 16. Ooh. So this is pretty gross. Can we plug in negatives? No, because remember, it's a 4th root. A 4th root, what times itself is -1 4 times? Nothing. Remember, a 4th root is the same as a square root of a square root. So that we can't put that in there. So 0, 1. Now, if you want, one thing I do like to do is with the 4th root, or if something like this, I don't, just find it. I will find that my brain is not working. It's Sunday. Find a decimal that, like, So, since the fourth root is the square root of a square root, right? 1/2 times 1/2. If I plug in 9, right? That's the square root of 3. The square root of 3 is about 1.5. So what I'll do is I'll go over to 9 and up 1.5, kind of just to keep me, like, so I don't go a little too aggressive. Because notice what this looks like. It's a square root, but just a lot skinnier, right? It's not going to go up very fast because you have to go over 16 just to go up 2. Over 27, not 27, just kidding. That would be cubed. Over 64, oh my goodness, my brain. 81, there we go. Third time's a charm. Over 81, up 3. So this is not going up very fast at all. So keep that in mind. So with these, sometimes I will find a decimal just to help me. Okay, so what would this one look like? Pause the video and try it out. So my vertex point, there's a 1. We'll make the inside 0. There's no outside because that -4 is multiplying. So I'm going to turn this chart into over, up, 1, 1, 16, 2. We're going to multiply times -4. Not that the 16 really helps, but, So over 1, instead of up, we're going to go down 4. 1, 2, 3, 4. And then this is -8. Let's see. What if we plugged in 9? Oh, I wouldn't know what that is. Over, nah, we'll just go with this. I don't have a calculator on me, so just do the best you can with it. Now, one thing I've been seeing is some kids did something like this in class, and they drew their curve like that. That is not right. That's a line. You need to show that this thing is that it curves. So if you only have a couple points, that's fine. But make sure you show that it's curving over like this. Make sure you do that, because otherwise that actually was a way better graph. My second one looked nicer. Make sure you show that this is a curve, right? It should be going off to the right because it doesn't increase very much. All right, how about this one? So starting point is -6, -2. Not doing anything. So it's 1, 1, 16, 2, -6, -2, over 1, up 1. Now this one actually I can fit it. 16, 2. So that's it. All right, so let's write down the kind of general rule here. So if we have an even integer, it's the square root of x, the fourth root of x, the sixth root of x, all of those. What will this look like? So that all pretty much looks like a square root. So it starts at the starting point, 0 for the parent function, and it just goes to the right. What if it's odd? The cubed root of x, the fifth root of x, and so on. So because it's odd, we can go to the right, but then we can also go to the left. So it's going to look something like that. Now, if you have something that's like x to the n over m, where n is not 1. So like this is really x to the 1/3, x to the 1/5. We did one earlier that was x to the 2/3. I would say where n does not equal 1. So like x to the 3/2, x, that's not an x, that's an n. X to the 3/2, x to the 5/3, stuff like that. I would just say make a table. Because honestly, I don't even know what those look like. I have to make a table. So plug in numbers, pay attention to what the denominator is. So like if the denominator is even, you know you're only going to the right. If the denominator is odd, you can go both directions. Just make a table because honestly, there's not a set rule for those. The one we did earlier, the cubed root of x squared, it looked like the bird, but something like x to the 5/3 might look way different. So I would definitely just make a table. All right, that's the lesson, and we are done graphing. This is a short unit. We're going to be moving on to operations next.